Hello and welcome back. In this video we're going to be discussing box and whisker plots. For those of you who are my students this year, the year of 2016, this should be review for you, so we won't be taking a long time. And yes, again, just a reminder, the Carolina Panthers play in the Super Bowl this coming Sunday. And so in order to commemorate the box and whisker, here we have the box and here we have the whiskers, although I would not recommend tugging on the whiskers of this particular cat. When we're done with this video, we will have reviewed how to create a box and whisker plot for a set of data, and of course you will be able to do your own. Let's knock out some quick vocabulary relating to box and whisker plots. The book definition of box and whisker plot is a graphical representation of a set of data which shows the distribution of data across quartiles. Of course, that begs the question, what the heck is a quartile? Well, a quartile divides a set of data into four equally sized groups. And when we get to the point where we actually make a box and whisker plot, you will see how it gets its name. The final definition to throw out there, because it will come up occasionally as you talk about box and whisker plots, is the range. And the range is quite simply, from a statistical standpoint, the distance between the lowest and highest value of a data set. So here are the steps for drawing a box and whisker plot. The first thing you should do is you should sort your data in ascending order, from smallest to greatest. And once you've done that, you will find the median of that data, and you'll also find the first quartile and the third quartile. May not mean anything to you right now, and it probably doesn't, but in a second we will see that in action. Once you have found these three pieces of information, you can then draw a box above the number line where the beginning of the box starts at the first quartile and ends at the third quartile. Again, this will make more sense when we actually do an example. Once you've got your box drawn, you'll be dividing it into two parts, and you'll use the median as the dividing line for that box, and that gives you the box part of the box and whisker plot. And now we're going to draw the whiskers, where we will extend the line from either end of the box to the upper and lower extremes of the data set. Now, if you're the average person, or maybe even the above average person, seeing these steps means absolutely nothing to you until you see it at work. So let's move to the next frame and let's do a box and whisker plot. This past weekend I sent out a survey to my Facebook friends, and we can discuss later whether or not this is a valid data set and whether it was truly random. But I asked them to answer some questions about their lives, and I asked all kinds of random questions. One of those questions was, what is your height in inches? And here's their responses. You can see the data here below. We've got everything from 78 inches, lots of things in the 60s. I think the lowest one here is 54. And we're going to use this data to create a box and whisker plot. Remember our first step. Our first step is to sort the data into ascending order. So here we go. I very quickly have sorted the data for us in ascending order, and our data starts at 54 and it goes all the way to 78. And I've listed here the information that we're going to need in order to do our box and whisker plot. You'll note that I have added two things to the list. The original list said we had to find the median and the first and third quartiles. Well, I've added these two things, the lower and upper extreme. And the reason that I put these in the list is because we're just going to put those into here, and it'll make it easier when we get down to actually drawing our box and whisker plot. Let's go ahead and fill in some of this data. Let's begin by filling in our lower and our upper extreme. The lower extreme is quite simply the smallest value in our data set, so 54. And the upper extreme is the highest value in our data set, so 78. It's real easy to find these two. There's the lower extreme, there's the upper extreme. And in fact, I'll just kind of go ahead and circle those so we can know what we're talking about. The next thing that we want to do is we want to find the median. Keep in mind that the median is the middle value. And we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 data points. So our median is going to be between our 8th and 9th data point. So let's count over. 1, 2, 3, 4, 5, 6, 7, 8. Our median is going to be in between the 64 and the 65 right in here. That's going to be 64.5. That is our median. Now let's talk about these quartiles. If you remember our definition for the quartiles, a quartile divides your set of data into fourths. We've already divided it in half. Here's one half on this side of the median, and here's another half on this side of the median. All we're going to do now is we're going to find the median of those two sets, and that will have divided our data into equal fourths. Again, the median divides it in half, and then we find half of our halves, and that gives us the fourths. Let's find our first quartile. In our first half of the data set, we have 8 values. Therefore, our median is going to be in between our 4th and 5th value. So 1, 2, 3, 4. The median will be between these two 63s. And of course, we want to check to make sure we're the exact middle. 1, 2, 3, 4. So 4 on one side, 4 on the other. Now this works out well for us. The median will be whatever number is between 63 and 63, which is going to be 63. There's our first quartile, 63. Now let's find our third quartile. Again, the second half of our set has 8 data points, so our quartile is going to be between the 4th and 5th one. 1, 2, 3, 4. Our quartile, or median rather, of the second half of the set, which turns out to be a quartile, will be whatever is in between the 66 and the 68, which is 67. So now we have done all of the quote-unquote math that we need to do to create a box and whisker plot. Using this information, we can now draw a box and whisker plot. Let's start by drawing a number line across the bottom of our screen here to give us some room. Here's our number line. I want to caution you about something. Don't feel the need to draw as many lines on your number line as I have done. This is just one that I have made out for occasions when I need it, such as this, and I can use it over and over and over again. So it's got 51 lines on it, so I can go anywhere from 40 to 90. I would recommend that as you draw your number line, that you could probably space it out and just indicate the numbers, evenly spaced like I have here, of 40, 50, 60, 70, 80, 90. Okay? And you know, we're allowing a little bit of estimation on this as you draw your own. But please don't sit there and draw every little line out like I have here. Let's take our data we have up here now, and let's go ahead and do our box and whisker plot. If you recall from our steps, once we have found the median and the first and third quartiles, now we're going to draw a box on our data line. Our box will start where the first quartile is on 63, and it'll end on 67. Okay, so if we look at our line here, this is 60. 1, 2, 3. The beginning of our box will start here, and it'll end on 4, 5, 6, 7 here. So let's draw that box. Alright, so here's our box, and it began on 63, and I'm going to go ahead and write that in right above the corner here. It began at 63, and it stopped at 67. Those are our first and third quartiles. Now the next thing that we're supposed to do is we're supposed to divide the box into two parts using the median as our guide. The median is 64.5. So I'm going to go here to the number line. This is 63, 64, 64.5. I'm going to draw a line that divides this box into two parts right here at 64.5. Okay. We have now completed the box part of our box and whisker plot. The last thing we need to do is we need to draw our whiskers. The next step tells us, the last step says to extend the line starting from the box going out to our upper and lower extremes. So let's draw a whisker coming out the right side of the box that stops at 78, which is going to be right about here. That's a little sloppy work. I'm going to put a dot there so we'll know it ends. And we're going to draw a line the other direction going to the 54. Now use a ruler when you're doing this on your paper so that your whiskers will actually be straight. And now we have a box and whisker plot. That's simply how you do it. Let's go ahead and mark our upper and lower extremes here. This is 54 and this is 78. And at first glance it might be, so what? What have we got here? Well, here's the interesting thing that we need to keep in mind about box and whisker plots. Let's highlight a couple of sections here. First of all, keeping in mind that our plot is divided into quartiles or fourths. That means that each one of these sections represents a fourth of our data. So a fourth of our data is on this whisker, a fourth of our data is in this half of the box, a fourth of our data is in this half of the box, and the last fourth of the data is in this part of the plot. If we look at our box, half of our data should always fall into the box if each one of these sections represents 1/4. And looking at our box, we've got a very small box in relationship to how big the whole plot is. So what that's telling us is, from a distribution standpoint, that half of our data is in a very small range. And in fact, there is something called the interquartile range. The interquartile range. And that is this section inside of our box. It is the place where half of our data is. So half of it is in this very small area right here. So it's a very concentrated data set. And that's really the main use for a box and whisker plot. So there's how you do one. That's our first example. I'm sure that there are lots of questions still, so let's do one more. All right, on the same survey that I asked all of my Facebook friends to give us, one of the questions was, how many contacts do you have on your phones? And here's their responses. And this I thought was really amazing. We had everything from only 10 contacts in their phone to over 1,000. And we want to make a box and whisker plot for this data. And this is probably going to create some challenges for us because of this large range. Okay, when we talk about the range, we got everything from 10 to 1,000. So we're going to have to be creative in how we graph this. But we can do it. So let's go through our steps. First step is to sort our data into ascending order. So here's our sorted data. And our lower extreme is 10. I'm going to write that in here. And our upper extreme is 1,051. That's going to be fun to try to graph. Let's go ahead and find the median. In this particular case, we only have 15 data points because one of the people answered on their survey that they had no idea how to find their contacts. So they left theirs blank and they put in that phrase, so we only have 15 data points. But that works out nice for us because if there's 15 data points, then that means that our median will be in the very center. We have an odd number, so 15, half of 15 is 7.5. It'll be the 8th one. So 1, 2, 3, 4, 5, 6, 7, 8. 122 is our median. And just to make sure that we've got the right median, we've got 7 on this side and 1, 2, 3, 4, 5, 6, 7 data points on that side. Good. Next thing for us to do is to find our upper and lower, our first and third quartiles. Our first quartile is going to be the median of the first half of our set. So the median of this piece, we've got 7 data points. That means we're going to go 3 on one side, 3 on the other, and 60 is going to be our first quartile. That's the median of this first half. We've got 1, 2, 3, 1, 2, 3. That's the exact middle of the part underlined in blue. Finally, we're going to find the third quartile, which will be the median of this part of our data, the part underlined in orange. We have 7 data points. So our median is going to be the 1, 2, 3, 4th piece. We have 3 on each side of the 278. So 278 is our third quartile. We have all the numbers we need in order to make our graph now. So let's add our number line and then figure out how in the world we're going to graph this. In this particular case, instead of using our good old standby number line, I decided I would sketch one out kind of like how I want you to do yours on your paper, because we do have such a broad range. And we're going to have to do a little bit of estimating here, but that's okay. When we have such a big range like this, it's acceptable to do it in that manner. Let's go ahead and first of all draw our box, and let's mark where our box should begin and end. The box should begin at the first quartile, which is about 60. So if the 500 is here and 0 is here, 60 is going to be about right there. I'm going to mark it in blue, the same color. And the third quartile is 278. That's going to be about right here, just a little bit over 250. I'm going to mark that in orange on my number line. You can see it's real faint right here, so I can know where to draw my box. So here's our box. It represents all the values from 60 to 278. Keep in mind that half of our numbers are in that box. Okay? The middle half of our numbers. Next thing we have to do is we have to now draw our median. We're going to divide the box in two by drawing our median. The median is 122. So if this is 278 on one end and 60 on the other, 120 is going to be about right there. Here we go. That's about 122. Let's go ahead and label some of these points. Alright, there is our median. Our third quartile is 278, so we can get a feel for the scale of this thing. And our first quartile is here, and that's 60. Okay, there's the box. The last thing we have to do to finish this box and whisker plot is to draw our whiskers out that go to our upper and lower extremes. Our upper extreme is 1050, so if this is 1000, our line is going to come out to about right here. And our lower extreme is 10, so that's going to come down to right about there. Let's put our whiskers in, shall we? Here's our whiskers. Let's label our endpoints. And now let's talk about this particular graph, because this gives us a very interesting situation. Keep in mind that each one of these sections represents 1/4 of all of our data. So 1/4 of our data is here, 1/4 is here, 1/4 is here. These are all relatively short spots, short pieces, and then 1/4 is way out here in this very long whisker. What that means is if there is only 1/4 of our data, and we had 15 data points, so this represents about 4 data points. They're very spread out because the same number of data points is in here, as in here, as in here, as in here. So these are much more spread out, and then the pieces that are in here are very close together. And in fact, if we look up at our list, we can see that they're very close together, 10 to 60. And then here we've got everything from 278 to 1051, much more spread out. So that's one of the things that a box and whisker plot tells us. Now I know this particular example could have been a little frustrating because of the scale of it, but don't forget, again, it's okay to estimate, but we want to get our scale as close to possible as we can for the accuracy of our plot. That's how you do a box and whisker plot. Tomorrow in class, we'll get a chance to do some more, and we'll start doing some things with that data in terms of interpreting it.